Well, nice to see everybody. So today we will continue talking about sets. So we'll wrap up the worksheet that we started a bit, that you worked on a little bit with the reading assignment um, first, and then we'll move on and start to combine what we did with direct proof in regards to set theory. So we'll look at some direct proofs for set theory. So we'll be working with worksheet 5 and worksheet 6 today, and we'll finish up worksheet 6 on Wednesday. So you've got homework due tonight, and then you've got your next homework assignment will be posted either later today or tomorrow morning. And that one is not due on Monday because Monday is Labor Day. So for next week, it'll be due on Tuesday, and we won't have class. We don't have class on Monday of next week. Sorry, I know you're sad. But so just one comment as far as the homework goes for now. So your first homework assignments have been graded by the grader, and I did post the grades, so you should be able to see your grade on the first homework assignment. And I just want to show you what it might look like in Canvas. But one thing to keep in mind, I just quickly looked through people's work, is that we would definitely prefer that you don't write your work in the margins of the assignment. So rather than just put false, 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 or whatever the answers are in the margins, I would prefer that if you're gonna kind of mark up the homework assignment, that you just put it in white space underneath the problem, or even better, you can just write it on a clean piece of paper. So we don't necessarily need to see the questions when we're grading. So the more space you leave, the easier it will be for us to read. And the other problem is you should always be explaining things whenever possible. So if you're not sure, please provide more details than you think might be needed. So question 3 was saying, okay, here's a conditional statement. If we know some additional information, decide whether these things are true or false. And so just writing it in the margins here would not earn you any points. But having some explanation would earn you full points. Rather than just say, I think this is false, I would like to see the explanation why. And so some people on the homework, wrote out the truth table, and that's really all you would need to do. So that would be sufficient. So I'll just say for anyone on question 3, that got no points on it because you didn't explain, you can resubmit that and I'll regrade it just because that was the first homework assignment, and you might not be clear what's expected. So if that was an issue for you, just let me know, and I'm happy to look at it once you write it up. Okay, so let me just show you where you can find your comments for your homework. Try this again. So here's our website, and just so you know, I changed the home page to be the module. So if you jump in at a different point, it's just the way I set up the web page. So here's all the stuff for this week. But if you're curious how you did on your homework, you can either go to grades or assignments, and then click on homework assignment 1. And it brings up what the homework is. And you might not see anything over here. So if you want to take a look at your grade, there might be some comments over here like thanks for the assignment or whatever, but your comments are going to be in this view rubric evaluation. So you should see a link here. And if you click on that link, it brings up like how many points each question was worth, how many points you got on that question. And if you get some points deducted, there should be a comment there to explain why. And so I think it would be really useful for you to try and check out those comments, make any corrections if you have any. But any questions about the homework and how you can how you can see how you did, get your feedback? So
I have a question.
yeah, sure, Heidi.
Okay, so you said we could resubmit the first one if we like didn't do well. Is this true for the first one or is this true for like all homeworks?
So let me say that again. Um, it's not that you can resubmit things. It's if you lost points because you were unsure of how much work that you needed to show, you can resubmit things. If you kind of went through a detailed explanation but got an incorrect answer, you probably got some partial credit if some of your explanation was correct, but maybe not full credit. So it's not that you can redo things necessarily, but you can, if you lost some points for not showing work, you're welcome to resubmit that. But if you have any individual questions about it, I'll just say maybe that's something that should be a private discussion. So if you're kind of curious about things, happy to chat with you, and yeah, you can try and earn some credit back on just this first assignment.
Sweet, thank you.
Yep. Kaden, yes.
Uh, I wanted to ask, so for not only this homework, but the homeworks going forward, will you be posting like the correct answers after it's all said and done, so that way we can see the mistakes that we do make? Or
I will post them. I won't post them immediately because I do want to give you the opportunity to make the corrections without the temptation of seeing the answer key.
Okay, cool. I just wanted to make sure that we would get it eventually.
Yeah, I will post those.
All right, thank you.
Yeah, well, you can't see it over here, but yeah, what I actually uploaded for my work is actually the solutions. I will add them up. I will upload it, but I want to give you a chance to think about your work and make some corrections before I do that. Any other questions? Okay. So let's then take a look at today's worksheet. So I want to start finishing up some ideas from the reading quiz that you looked at. So the reading quiz dealt with things like intersections and unions and differences of sets. And some of the questions went really well. These were the two questions that were the most missed. So this was thinking about the union and the intersection of rational numbers and the integers. So when we're thinking about the intersection, just recall here we're looking for the set of all elements that are in the rational numbers and all values that are in the integers. And rational numbers are anything that can be written as a fraction, this over that. And in particular, any integer like 5 can be written as 5 divided by 1. So every integer is in fact a rational number. So when we take the intersection of these, we would just get back the integers. Those are the only values that are going to be in the integers and in the rational number. So something like 1/2 isn't in the intersection because it's not an integer. But when we take the union, now we're saying, let's consider all elements that are either in Q or in Z. And again, since all of the integers sit inside of the rational numbers, this one would just wind up being all of the rational numbers. So I want to give you a chance to ask any questions if you want me to clarify that one, since these two were certainly missed by a few people. So if you have some questions, you may not be alone. Okay, so these we did last time, yes, and this kind of came up that, sorry, this one is indeed false because not only the top one is false because 3.5 is not an integer. This one is false because when I plug 3.5 into this equation, I actually don't get 0. So that's why it would not be in there. Otherwise, this should look familiar from the reading quiz. You looked at the union, intersection, and difference. And so today we're going to think about things like set equality, subsets, and complements of sets. Okay. And so these were some things that you took a look at on the reading quiz. So I want to take a look at 3. So we use this symbol here to be a subset. So for example, just kind of thinking about the previous example we were looking at, we would say that the integers are a subset of the rational numbers, which are a subset of the real numbers, which are a subset of the complex numbers, for so on. So these number systems are almost like these Russian dolls where one thing sits inside of another, sits inside of another. So let's try and think about whether these statements are true and false. So in statement 1, these things are referring to interval notation. So when we say something like the interval, the closed interval from 0 to 1, this is the same thing as saying all x in the real numbers such that x is between 0 and 1 inclusive. That's another way we could write out that set. And just so you know, this one is saying 1, 2. And one thing that's slightly annoying in mathematics, so I apologize, is that sometimes we use the same notation, different contexts, and it means different things, sort of like English. Anyway, so here, this is not a coordinate 1, 2, but this is the open set, the open interval. So this would be all x values from 1 up to 2. And in that case, we don't include them. So statement 1 is saying, what would I get if I took the intersection of these two sets? Would I get the element 1 back? So you can give me a thumbs up or a thumbs down. Okay, so we got some thumbs down. That's right. So this is not true because 1 is in here, but 1 is not in there. So this is a false statement over here. Okay, statement number 2 is the empty set. That's what this 0 with the slash through it means. So the empty set, again, is a set that contains no elements. So is the empty set a subset of the real numbers? What do you guys think? So we have some differing opinion here. And so what we would want to say is, okay, is every element of the empty set in R? That's really what we're checking. So how many elements does the empty set have? It has no elements, right? So this is like a vacuously true statement. All we're saying is every element of the empty set is that in R. Well, the empty set has no elements, so thus every element of the empty set, which is none of them, are indeed in R. So the empty set is a subset of every single set that you can imagine. So this one would be true. What do you guys think about 3? True or false? Got a thumbs up from somebody. What do other people think? I would like to get a sense of more than 1 or 2 people. Do you guys like the polls better because they're anonymous? Okay, so some people are giving thumbs up. And so again, here what we'd like to check is every element of this set inside of here? And there's only one element in that set, which is 1. 1 does occur in this set, so this one would be true. And just a subtle difference in question 4 compared to question 3 is this one has empty subset notation, and that one has inside of the set. So what this is asking is a different question. So this is saying, is the element the set 1 inside of 1, 2, 3? And here, this would be a false statement. And you just want to be careful in that there's a difference in saying the number 1 as opposed to the set that includes the number 1. So we would say that 1 is an element of 1, 2, 3. But the set 1 is not an element of the set that contains numbers 1, 2, 3. So it's just a subtle change in notation, so just watch out for that. What do you guys think about question number 5? The intersection of the empty set and the set 1, 2 is the set 1, 2. Good, that is thumbs down. Good, right? Since the empty set has nothing in it, the intersection of the empty set and any set is going to be the empty set. Okay, in question number 6, now we're thinking about this set that contains 2 things. One thing in that set is the empty set. The other thing in that set is a set that contains the empty set. So this is asking, is the empty set an element inside this set over here? What do you guys think? Okay, we got some thumbs up. That's right. So the empty set, yes, it's listed right there. So that is definitely a true statement. And then for this last one, I'm taking the intersection of the set that contains the empty set and the set that contains the empty set and the set that contains the empty set. What do you guys think about this one? Okay, yep. So this one would be, I take the intersection of these 2. Let me say that here, this would be a false statement. And the reason why this one is false is because I see the set can, no, I'm sorry. This, yeah, this is false. Yeah, we should just get the empty set out of this. So if I look at the intersection of the set that contains the empty set and the set that contains the empty set and the set of the empty set, this is the only thing that sits in both of those sets. So in this case, the intersection would just be empty set and not the set containing the empty set. Okay, any questions? So we've been doing this pretty hand-wavy. All of these things are really statements, conditional statements, that we want to prove a little bit more carefully. If you were kind of not so happy about just me making these decisions off the cuff, yeah, let's think about how we can formalize some of these questions. But any questions in the meantime? For those that maybe don't have the next worksheet, I'm just going to upload it into the chat. And this would be worksheet 6, which is going to be direct proofs with sets. Here it is. So that may take a second to upload there. Nope, it's uploaded. Okay, so we're gonna jump over into chapter 8, and let me just say, chapter 8 deals with proofs involving sets, and it might involve some other proof techniques that we haven't gotten to just yet. So really what we're thinking about here are direct proofs involving sets. And so there's kind of 3 different types of proofs that I would like to work with these sets. And one of them is, how do we prove that an object is an element of a set? How do we prove that one set is a subset of another? And then how can we prove that 2 sets are equal? So first up is, this is one of your reading quiz questions for next time will be exactly this. How can we show that an element A is a part of some set X, which the set X is defined based on some statement P of X. And the way that we show an element is inside of a set is we show that if we set X equal to A, then that statement is true. If the statement is not true about A, then A is not in that set. And so one definition and some notation that I want to just clarify at this point is over here. So we say that A divides B if A times some integer C gives me B, right? So you might have an idea of what a divisor is. We're not changing that definition. We're just going to formalize that a little bit. And so we use this notation of a vertical bar to denote that something is a divisor of something else. Okay, so for example, we would say that 2 is a divisor of 4, since we can write 4 as 2 times some integer. Okay, so if we want to prove that 18 is an element of this set, then what we need to show here is the statement P of X that's defining this set is it's saying X, first of all, is an integer That's one way that we could restate that, right? What we're saying here is that both 2 and 3 should be divisors of x. So what we're thinking about here is if we set this number equal to 18, are 2 and 3 divisors of 18, is that a true statement? And this is indeed true. Okay, since we can write 18 as 2 times an integer or 3 times an integer. So that would prove that 18 is in that set. So we were a little more informal on the previous worksheet. But sometimes proving something really basic actually winds up being the hardest proofs to write sometimes. Any questions? Okay, so what I want to focus on then today is how do we prove that one set A is a subset of another set? And so in order to prove that, by definition, we say that A is a subset of B if every element in A also is in B. So if we're going to prove this directly, this is really a conditional statement, which is saying if X is in A, then X is in B. If that's a true statement, then we've proven that A is a subset of B. So we can just frame this in the same setting of how we proved conditional statements directly last week. And that is we start by assuming P is true. So we assume that A is an element of set A. And then at the end, what we want to show is therefore A is in B. Great. Since A in set A implies that lowercase a is also in set B, that would prove we've got A inside of B. And then, yes, this is the fun part inside of here is what connects those two thoughts. Any questions? So for most of the time, I want to give you a chance to just work on some of these proofs. So I'll leave 2, 3, and 4 for you guys to work on in a second. So my suggestion to you when you work in your groups might be to start with this one, then move to this one, and then think about this last one. But I will take this one that we can work on together, just so you get a feel for what these proofs look like. So again, what this is really saying is if X is in A intersect B, then X is in B. So we're trying to show something like this. And you might think to yourself, clearly, obviously, that is true, but let's just make sure we can prove this more carefully. So this proof, again, we can just start with, let's suppose X is inside of A intersect B. So then this would tell me, by definition, of the intersection, we know that, excuse me, that X is inside of A and X is inside of B, right? It has to be inside of both of those sets if it's in the intersection. And really, that was the part that we needed. That's what we needed. So so since we've shown that X inside of A intersect B implies that X has to be an element of B, then it follows that A intersect B is a subset of B. So this is a little bit more basic than some on the previous page that I'd like you guys to work on, but I did just want to go through one together just so you get a gist of how the proofs generally flow. But any questions? Okay, so I will then break you guys up into groups, and again, we'll be working on the previous 3 problems. So don't move on to question 6 or 7 or 8. So that's stuff that we're going to work on next class. So if you get through those 3 proofs and you're still in breakout rooms, just leave and come on back to the main room. That way I'll know when you're done. But in the meantime, Nat and I will be checking in on the groups. But any questions before I split everybody up? Yeah, Victoria.
Can you go back down real quick? Perfect, thank you.
Yep. Okay, welcome back, everybody. Okay, so I think Nat, you figured out how to jump in and out of rooms, from what I could see. Yes. Yeah. Oh yeah. So you might have caught both Nat and I saw us. We were both jumping through the groups. But sorry that I forgot to define what a complement is before we started this one. It was on the previous sheet, but I kind of missed that. So I think at this point we're probably all caught up with what it means to be in the complement of a set. So the groups that I was able to meet with mostly talked about question 3. So let me just kind of summarize what kind of most groups were thinking about, and possibly maybe some groups did it differently. But the gist is you kind of start by assuming we've got something in there, and then in the end, what we're hoping to show is that it has to be in there. We kind of start by supposing it's in the set on the left, and then we want to show that it has to be in the set on the right. So kind of a good plan of attack is, okay, if X is in A minus B, then what is that by definition, right? Let's just write out what that means. And so that would mean that the definition of the difference of 2 sets would mean that it's in the first set, but not in the second set. So that's what we wrote over here and over here. And I'll just say, as you're writing out these proofs, you're welcome to use the notation. You're welcome not. You're welcome to say, this means X is an element of A. So you don't have to use those symbols if you don't want to, but it's certainly important to be able to read them in case somebody else is using them. And you know, what this kind of color coordinating was trying to indicate is if you stop here and you kind of say, okay, I know what the the definition of set difference is, and I know that ultimately I'd like to get here, if you get stuck, then you can start at the bottom and think about how you can connect these two ideas. So in the end, if we want to show that X is in the intersection of these two sets, then what we would want to show is that X is in A and X is in B complement. And so therefore you can kind of have these definitions meet in the middle somewhere. And so for this one, really all we just need to say at this point is, I know that X is in A, we just really want to restate this as saying, well, if X is not in B, that means it's in B complement. Okay, great. Now we've got X in A, we've got X in B complement, so it is in the intersection of those two sets. And then I do think it is nice to just summarize what you just did with one last sentence. For example, like, since X is in this, implies that X is in the other set, then that is the definition of subset. That would wrap it up. Any questions, or did any groups go about this any differently? Okay, so then let's take a look at number 4, which is flipping the direction around, right? So now we want to show that A intersect B complement is a subset of A minus B. Does somebody want to take me through the discussion that came up in your group for this one? Okay, I will pick a group at random. I'm going to say group number 3. That happened to be Alex, Kaden, and Basim. Were you guys able to do it, first of all? Number 4?
Yeah,
Okay.
we figure we're working on it.
Okay, do you mind just sharing where you were at in this one?
Yeah, sure. So our kind of mentality was, since it's kind of like 3 there, we decided to kind of take it in the reverse. So we obviously wanted to take our first statement of, like, supposing the A and not B,
Okay.
and kind of define what that means.
Mm-hmm.
And so we kind of define that, meaning that X is included in all of A but not B.
So let's say, mind rephrasing that again, Kaden? Sorry.
Oh yeah. So it's the idea that for our X,
Mm-hmm.
all of so X exists within, like, the parts of A that are not also in B.
Okay.
Sorry, I worded it a little weird the first time, but yeah.
So I'm gonna just include one thing. You're certainly right. But let me just kind of carefully make sure we write out these definitions. So like, yeah, what you're saying is right. X is in A, but it shouldn't be in the intersection of those two. But more normally we just say, like, okay, the strict definition is it's in A and it has to be in both of those sets.
Okay.
Yeah.
So then for the next step, we kind of did that same thing, where we knew that because of those established sections that it has to be in A but not in B. that applies to our A minus B, since A minus B is the area of A without the area of B.
Yep. Yeah, so I think at this stage, yeah, like what we're hoping to get is this. And if you're like unsure of how to connect those ideas, then you can start working up from this statement. So like what would come before you said, therefore X is in A minus B would be, right? So that's what it means by definition to be in the difference of those two sets. And I think that pretty much that's the only connection that we need between those two, right? Saying that X is in A and X is not in B, or is in B complement, is the same exact thing as saying X is in A and not in B. Good. I think that's exactly what you were saying there with your group. So thanks, Caden. Yeah, and so since X is in A intersect B hat, or B complement, this implies X is in A minus B. This would be enough to say that A intersect B complement is a subset of A minus B. Okay, so we can start next time talking and comparing our notes on number 2, and then think about how we can prove set equality. But just to connect what we're going to do next time with what just happened in 3 and 4, what we just showed in 3 and 4 is we showed that A minus B is a subset of A intersect B complement. And we showed that A intersect B complement is a subset of A minus B. This would imply that these two sets have to be equal to each other. If one sits inside the other and the other sits inside the other one, okay, that's how you show set equality. So this is what we'll take a look at next class. But this is one of the questions on the reading assignment. Is just going to flat out ask you kind of what's in this box over here. So how do we prove that two sets are equal to each other? We need to prove two things. So it's nothing new because we're talking about how to prove subsets, but it's just two proofs for the price of one. Okay, so I will stop here. Homework is due tonight, and there's a reading quiz due before Wednesday's class, and I will get the video to go along with those questions up today as well. So if you have any questions about today or homework or something, I'll stick around. You're welcome to stick around. Otherwise, thanks everyone for a nice class. And I'll see you all on Wednesday.